Math 110 students. We are in 3.6 today. We're going to graph rational functions today. Now, in this particular time, normally I really want you to be able to do this stuff by hand and not rely totally on your calculator. But on this one, we are really going to incorporate the calculator with us. And even though in theory, this is about you learning how to graph it by hand, we're going to let the calculator kind of work us through that. But here are the basic things that we want to talk about today. We're going to kind of put together what we've been talking about with rational functions up to this point and graph them starting by hand, but also with the graphing calculator as our friend. So let's go to the slideshow from this current slide. All right, graphing rational functions. We're going to start with r of x equals x minus 1 over x squared minus 9. What makes this a rational function? Remember that rational functions are ratios. In other words, they're fractions, but they're fractions that have a variable in the bottom. So now we have the x squared minus 9 in the bottom, and that's what makes it a rational function. Now I want to go over, I'm going to have to stop this for just a second and turn back on my camera, which of course is nowhere close to being open. So hold on just a moment. All right, so here we are. We've got the rational function x minus 1 over x squared minus 9. And the things that we're normally working with these guys are domain, intercepts, and asymptotes. We've been talking about all three of these with rational functions. We're going to put them all together to help us graph them. First of all, what's the domain? All right, well, remember, your first step here is you want to factor this guy out and make sure nothing will cancel out. So my top is x minus 1, x squared minus 9. This is the kind where the middle terms cancel out. It's x plus 3, x minus 3. Okay, that's how that bottom factors. Nothing can cancel each other out. And the domain is tied to the things that make the bottom equal to 0. So what would make the bottom of this rational function, x plus 3, x minus 3 equal to 0? Well, that would be if x plus 3 equal to 0, or if x minus 3 equal to 0. Subtract 3 from both sides. This would be x equal to negative 3. Add 3 to both sides. This would be x equal to positive 3. So our domain are all numbers except these, because these would be the ones that would make the bottom equal 0. So our domain then is going to be the set of all x such that x does not equal negative 3 and x does not equal positive 3. Okay, that's your domain. You can plug in any x value except these two. These two will break the equation basically. And remember that domains are attached to the vertical asymptotes. All right, so where are our vertical asymptotes? They're going to be at these two values that x can't equal. So at x equals negative 3 and at x equals positive 3, you're going to have vertical lines showing that your graph can't touch there. Your graph will get infinitely closer to it, but it will never touch it. All right, then that's your domain, your vertical asymptotes. What about intercepts? What are intercepts? Intercepts, the y-intercept is where x equals 0, and the x-intercept is where y equals 0. So let's do the y-intercept. The y-intercept is when x equals 0. So that would be up top 0 minus 1 over 0 plus 3, 0 minus 3. So up top, it'll be negative 1. And on the bottom, it'll be 3 times negative 3, which is negative 9. So this is our y-intercept is when x equals 0. Our y-intercept, okay, is going to be x is 0, y is 1/9. Okay. Now your x-intercepts, those are the same thing as what we call zeros, are going to be when the entire function equals 0. So your y equals 0. So what x values would have the entire function equal to 0? And with a rational function, as long as the top equals 0, the whole thing will equal 0. That's how fractions work. If you have, 0 over 3, 0 over 3 is 0. So the whole thing will equal 0 if the top equals 0. So what would make x minus 1 equal 0? Add 1 to both sides. Okay, x equal to 1. Okay, so our x-intercept is that when x equals 1, y equals 0. Okay. All right. Last is our, you remember our old horizontal and oblique asymptote cheat sheet? So we know our vertical asymptotes, but what about horizontal or oblique or slanted? All right, well, that's when we have to take the degrees up here. So the degree of this top one is 1. The degree of the bottom one is 2. So our n is less than our m. Actually, our m equals n plus 1. Let's see, do we have that? N equals n plus 1. Yes, okay, this n, nope. N is less than m. This is number 1. All right, then the line y equals 0 is a horizontal asymptote. So this is the easiest one. Y equals 0 is a horizontal asymptote. Okay. All right, so let's take from that and let's kind of put it together here. All right, I'm just going to use let's see if I can share this. Let's just use one of my little graphing thingies. Okay. All right, so here's what we know about this function. I'll put this guy right here. We know a few things. All right, we know that we're going to have vertical asymptotes at x equal to -3. So 1, 2, 3. So we got a vertical asymptote here. And x equal to +3. 1, 2, 3. We know we have a y-intercept. When x is 0, y is 1/9. So it's really, really close up there. And when x is 1, y is 0. So there. And we know that y equal to 0 is a horizontal asymptote. Okay. Now you can cross horizontal and slant asymptotes. All right. So I'm going to say we've got some ideas here, and what we could do is test a few points out here, test some more points in the middle, and test some points there. But let's also look at it on our graphing calculator. Now, how do I put this rational function in on my graphing calculator? All right, let's clear this guy off. Put your parentheses around your top. So x minus 1 parentheses divided by, and then parentheses around your bottom. X squared minus 9 was the original one. Let's zoom to a standard window. Standard window, I think, is -10 to 10 on the x and -10 to 10 on the y. All right, so it's interesting that we do, even though we have this horizontal asymptote of y equals 0, it does cross it in the middle, but it gets infinitely closer to it out that end and out that end. And here you can see they're not drawn well, but you can see the vertical asymptotes of x equal to -3 and x equal to +3. So we're using information from the graph and also allowing for us the calculator to help us. All right. So we found all of this and kind of 0, 1/9. I drew mine wrong. I drew mine down below a little bit, but it was above it. So we've got this much, and they tested a point over here and a point over there. But what you would end up seeing as you graphed it is that this is what the final graph would look like. Okay. So what did they do? They factored it and made sure it was simplified and found the domain. Then they plotted the intercepts, used multiplicity to determine the behavior of the graph at those intercepts. I forgot to talk about that, but all of our all of our intercepts were single multiplicity. That's why it crossed there, didn't just touch. Found vertical asymptotes, found horizontal or oblique asymptotes, and zeros. All right, let's do one more. We'll do as much as we can by hand, and then we will add in our calculator here. All right, so go back over here to, got mine written out here for me. All right, let's find our domain. Remember, domain is tied to when the denominator equals 0. So when does x equal 0? When x equals 0, okay? So our domain is the set of all x such that x cannot equal 0. And that means I'm going to have a vertical asymptote then at x equal to 0, okay? My intercepts are when, so my x-intercept will be when y equals 0. My y-intercept will be when x equals 0. So when x equals 0, I get 0 minus 4 up top over 0. Ooh, look. Alarms are going off. So there's no y-intercept here. No y-intercept. Okay. The x-intercept is when y equals 0. This whole thing is y. So 0 equals x minus 4 over x. All right, remember, for a rational function in lowest terms, the whole function will equal 0 when the top equals 0. So I've got 0 equals x squared minus 4. If you want to solve that, you could use the quadratic formula, but boy, it's helpful if you recognize how to factor a perfect square minus a perfect square. This factors x minus 2, x plus 2. Okay. And so if you multiply two things, you get 0. Either the first equals 0 or the second equals 0. So x equals 2 or x equals negative 2. So these are our zeros. These are our x-intercepts. All right, so x-intercepts. They each only occur once, 2 and negative 2. So the graph's going to touch there. They have a multiplicity of 1. It's going to, when x is 2, y will be 0. And when x is negative 2, y will be 0. And the graph's going to cross at both of those points. All right, last but not least are our other asymptotes. So we know about our vertical asymptotes, but what about horizontal or slant? All right, top n is 2, m is 1. If n is m plus 1, so n is 1 more than the m, we're here at number 3. We're going to have a slant asymptote, an oblique asymptote, quotient found using long division. Well, this one actually is pretty easy to use, long division. So we're going to take the bottom, divide it into the top. What times x is x squared? That would be x. X times x is x squared. Okay, subtract them, you get 0. Let's see, bring down the negative 4. X doesn't go into negative 4. So this is all by itself. That's just the remainder here. This is your slant asymptote. Y equal to x. That's your oblique asymptote. All righty. Let's put all that here then on our little graphy poo. Hopefully you can see here I'll write the y equal to x up higher. Okay, so this means our slant asymptote is y equal to x. All right, so we had a vertical asymptote at x equal to 0. So that's basically the y-axis. Okay, that's our vertical asymptote. We had a horizontal asymptote at y equal to x. That's this line that, y equal to x. So 0, 0, 1, 1, 2, 2, 3, 3. So it's this one that goes right. So that's another asymptote. Okay. X-intercepts at 2, 0 and negative 2, 0. All right. Now you could test a few more points, but I'm wondering if it does something like this. That's kind of what I'm thinking it's going to do. Let's look at it on our graphing calculator as well. Okay, so it's x squared minus 4 over x. Clear that off. All right, up top, parentheses, x squared minus 4 divided by x. And let's graph that one. Yeah, that's what it's doing there. And so it didn't really draw it didn't draw our slant asymptote at all, but we can put our slant asymptote on there ourselves, y equal to x, and I'll make it a dotted line. So it looks like a slant or like an asymptote. Dotted line. There we go. That's a dotted line. All right, that's our slant asymptote there. All right, and so let's look at it in the book, in our PowerPoint as well. That one. And you see that's what it ends up looking like. All righty. I think that should help you there in 3.6a, and your word for the day or word for the video is sketch, because we're kind of sketching these and using the graphing calculator to help us see if we're really thinking about it right. All right, have a good day, and always use that Ask My Instructor button if you're having any problems in Pearson. We'll see you later.